In this video, we're going to be taking a look at our next topic, which is going to be extended access lists. Now, extended access lists are pretty straightforward to work with if you've never worked with them before. If you're familiar and understand how standard access lists, then extended access lists are not that much of a stretch. So, standard access lists match on the source of the traffic and the entire IP stack. So TCP, UDP, ICMP, ESP, the whole 9 yards. With extended access lists, we can go ahead and match on a bunch of individual subprotocols. So if we were to go on, say, router 11, and go on here and type in, go to global config and type in IP HTTP server, and then the IP HTTP server or authentication is going to be local because I want to test out connectivity to the router via HTTP. I'll also enable crypto, so crypto key generate RSA modulus of 1024, so we can enable IP domain dash name is going to be lab.local, and then we'll enable this so we can have SSH up and running. So we have SSH enabled, and then after we have that going, that's pretty much where I want to stop for the moment. And what we can do from here is we can take and play around with this a little bit to see exactly what we need to get done. So the IP access list extended command, we're going to type in extended and the name. In this case here, we're just going to type in ACL and then ACL, and then whatever it is the name of the ACL is probably going to be doing. So we'll just say filter for the moment. And underneath here, just like in standard access list, you can say permit or deny. You can define a sequence number. We haven't gotten to reflexive access lists where we'll deal with, or lock and key, where we'll dive into dynamic access lists and then reflexive access lists. But we'll talk about those in an upcoming video, where we're going to be taking a look at just the permit and deny options for right now. So we're going to say we want to permit, and then we need to specify the transport. So what are we going to permit? So we can define the protocol number if we happen to know that, or we can say the authentication header if we're doing really heavy duty authentication, EIGRP, ESP if we're doing phase 2 or the data plane encryption, GRE tunneling, ICMP for pings, IGMP for a host trying to signal to a the last hop router, which is the router that connects down to the receiver if they want an multicast flow. IP if we're going to tunnel IP inside of IP. I don't know what NOS is, whatever that might be. An object group, we'll talk about object groups later. OSPF, the PCP, payload compression protocol, never heard of that. PIM, secure copy. Stream control, never heard of that. And then we have TCP and UDP. So what we're going to do in here is we're going to say permit TCP from the source address of 10.1.1.0 to any, and the wildcard bits allow us to be specific as to how much of a match that is. So 0.0.0.255. That's really no different than what you did in the standard ACL, except for at this point we would have never have defined the transport. We did the transport here, and then we had to define who we're going to go talk to. So we're going to say in this particular case it's going to be any destination is fine, and then we have to specify what part of the TCP payload do you want to focus on. If we're going to specify on the port number, we're going to say port number, and we're going to say 80 for web. So we're going to allow web communication inbound to us. Now, here's an interesting thing. We haven't talked about control plane protection or control plane policing yet. So we're going to take this variable, and we're going to take it, and we're going to type in do show IP interface brief, and we're going to say on interface gig 0/0, I'm going to type in IP access group, and the access group name is going to be ACL Filter. And I'm going to apply that inbound. Okay. Now by me doing that, I'm going to try to ping my default gateway. Oh, I'm sorry. Ping 172.16.12.1. How come I can't ping it? And notice behind the scenes that I lost my EIGRP adjacency. Any idea why that happened? Well, the reason why it happened is because in the filter, do show IP access list, I only permitted web traffic. So should I be able to open up a web page to 172.16.12.1? Let's go ahead and stop that. One 172.16.12.1. Let's see if it's even matching on the access list. Yep, there's matches. Definitely matches. It's got to go through the switch, which is a place of contention. So let's go. We have a couple of little things we have to focus on first. So we're going to type in do show run section HTTP. Pretty sure I turned on the HTTP server. I did. So we're going to say that we need to modify this access list. So IP access list extended. But part of the reason why we can't reach it is because there's no routing. So let's fix that first. So we'll type in ACL filter. I'll type in permit EIGRP any. So that should immediately allow the EIGRP adjacency to come through, and it does. So we'll do a do show IP access list. So that's being allowed to come through, and so if we resynchronize this, there we go. We'll type in Rob and Cisco, and there we have we are authenticated to router 11's web page. So if we hit the up arrow, we have all kinds of matches now, which is great. Now if I wanted to ping that IP address, will that work? Nope. Now I'd have to allow another thing. I had to type in permit ICMP any. If I did that and I hit the up arrow again, now it's going to work. Hit the up arrow. Now it's the ICMP is working. So there's a few things that you need to be careful of when you're doing this. One of the other things that we can do is that's the majority of most configuration, but notice the other thing that's not working now. Notice I have a little exclamation point here over the web, the internet connectivity. I'm blocking DNS through UDP. So if I was to type in permit UDP any, and then give that a couple of seconds and hit the up arrow, you would eventually start to see UDP connectivity. And so if I came over here and I tried to ping google.com, I can ping it, and that the DNS issue goes away if I hit the up arrow. And now we have UDP matches. So I've matched on TCP, the routing protocol, ICMP, and UDP. So should I be able to web browse to, I don't know, google.com now? Let's see. Now, mind you, traffic has to go through the switch and router 11 and then go out to the internet and come all the way back. So it might take it a couple seconds for it to respond. But in most cases, it should work pretty easily because it should be allowed through. Actually, no, it won't. It will not work because I said match traffic towards... So right now, I don't have a deny any log created. So this would be one of those times where a deny IP any log would come into play. So let's type in 100 and, oh, it is working. Okay. So let's see what it matched on. Oh, never mind. It's going to work. My bad. That's my fault. The reason why it's going to work is I said any destination. I didn't specifically state only to. And actually, let me go and type in no 10 and type in, let's type in the permit TCP any to this destination, but in this, we'll type in 10, go to the end, and we're going to say that to 172.16.12.1 equal to dub. Oh, that's because I host. So I'll type in do show IP access list. So now if I go back to here and I resynchronize this connection, and if I go back to here on this page and I resend it, that should be allowed. We should have hits on that entry, and we do. But on the connectivity out to Bing, this should be blocked now, because there's nothing else in the line. So right now, this line of config is saying allow traffic from PC1 and PC2 to talk to the web server at 172.16.12.1, which is R11. This one is saying allow EIGRP between switch 1 and router 11, or switch 2 and router 11. Allow pings from anything to anything, and allow UDP from anything to anything, which basically says allow DNS. So the TCP connection here to I should not receive any web communication back. So that's basically going to hinder any type of communication that I have. This eventually should die out. So if we were to try to go and type in IP or netstat-nao, we should have a lot of stuff trying to go out. We have, okay, so right here we have on the connectivity, we have SYN sent, right? These guys right here, I'll go ahead and mark what I'm looking at. We have a SYN sent and right here. So these are all going out to Google DNS and Bing trying to resolve a web page. We have a SYN sent. So the first portion of the TCP three-way handshake has been forwarded. But we have not gotten an ACK back, and we have not sent a SYN ACK out. So the second and third portions of the connection are not coming through. So if I was to go in here and add a line and say 50, or let's add 11 and type in permit TCP from a source of 10.1.1.0, 0.0.0.255 to any destination and equal to dub, and then on, which is web traffic, and then we'll do 12, we'll say, let's do to HTTPS. So eventually, so as you can see right now, the connection says the Internet Explorer can't load the page. So I'll go ahead and hit the enter key, equal to, we'll say 443. There we go. So maybe it doesn't understand dub, or HTTPS. So if we type in do show IP access list, we should have entries now for from us to anything online. So if I was to go ahead and resend this, it pulls it up right away. We hit the up arrow and we do the NAO, we scroll back up, we should have a bunch of established, and we do. A bunch of stuff is established to port 80. So that's exactly what we're looking for, right? We're looking for stuff to go out and find its way to wherever it is it's got to go. Now, in situations like that, knowing how to filter this traffic is really, really important. So I'm going to go ahead and I'm going to do one more. I'm going to type in the next line. I'm going to type in is deny IP any, and I'm going to log the traffic. Now, there's two different ways I can do this. There's the log and there's the log input. If you are on a switch is doing layer 3 functionality, maybe it's a default gateway or something along those lines, then I would recommend the log input in situations where you need to see, okay, where's the traffic coming from? Who's the source? If you need more than just a log. but that's a little bit more resource intensive. So what I'm going to go ahead and do is I'm going to hit that, and now I'm going to go and I'm going to, since I'm on the Bing website, I'm going to type in SSA or Putty. I'm going to download Putty. Download the executable file. It'll take a couple seconds for it to load. I'll come out here and I'll do the 64-bit executable. I'll say save. And we'll save to the desktop. We'll say save. It's about a meg in size, so it's actually coming down quite quickly. 112K a second, which is pretty good. It's about it's about ISDN speed. Click on close, and then I'm going to go and click on Putty. And now I'm going to come in here and say we're going to not ask before running. I'm just going to go ahead and say pin to taskbar. And then in here I'm going to type in 172.16.12.1, and I'm going to go ahead and I'm going to open it up, which is an OpenSSH connection. I'm going to reach out, and notice what I have right here. The syslog message generates for us. It says deny traffic coming inbound from 10.1.1.2 to 172.16.12.1. So this tells us who's doing it. Now if we were to take this a step further and type in log input, and let me just do show IP access list real quick. It says log input now. So what this will tell me is the next time this, and this is telling me that it won't connect. So I'll go ahead and I'm going to resend it. Restart the session. Now the log input is nice on a switch, because now it's going to tell me which port the issue came in on and what the source MAC address is, and the source port or source IP and the port. So it's kind of cool in this regard. This is all related to a single endpoint, which is nice. I get to see that as I'm going through. So what I can go do now is I can hit the up arrow, and I can type in, I'm going to say 13. I'm going to type in permit TCP from 10.1.1.0, 0.0.0.255 to the destination of host 172.16.12.1 equal to 22, and I'm going to log. Now, TCP, not TCY. Not sure where that came from. TCP. So there we go. So now the log, again, is going to allow me to communicate what's going on. Now, I should be allowing that traffic inbound. I'm going to click on OK. And I'm going to restart the session. Restart session. And the network connection was dropped again. Now, this is, it's actually interesting that the ACL filter shows up the way that it does. Now, notice what it says. It was permitted. But why did my connection die? Do show run section line. This actually has nothing to do with filtering. It's a, the transport input is open. Do show IP access list. I thought it was a transport input issue. Let's go see if, aha, that's why. Okay, so the ACL filter took and dropped the traffic, permitted the traffic as it was coming inbound. But let me go do a, let me exit out of this guy and type in IP access list standard of VTY access, and type in no 20, and then type in deny 10.1.1.0, 0.0.255, and this time I'm going to log the traffic as it comes in. I'm going to try this one more time. Resynchronize the session. But now you have a different, so the ACL filter permitted the traffic, but what's actually interesting is if we look at the do show IP access list of VTY, let's see, this guy has, oh, that's because I put it in the wrong order. That's my fault. So no 40. We'll type in, hit the up arrow a couple times. We'll type in 20. You guys are probably like, you're not doing it right. Yeah, I make mistakes too. Click on OK and do the restart the session. I'm still dropped, but this time I'm still dropped by I'm permitted by the ACL filter. Even though I logged it, only one of those access lists got logged. You can see that happening. So what I'm going to go do is I'm going to go ahead and say no 10, and I'm going to say no 20, but in this case here, oh, so it did finally log. So that's just weird that it took so long to do so. I'll type in permit, there's 10 permit 10.1.1.0.0.0.255 and hit the enter key. So now if I come back over to this one more time and restart the session, now it pops up. I go log in as Rob and as Cisco, and I'm logged in. If I type in who, it tells me that I am, I have IP domain, and it logged it in, and guess what? It permitted the traffic to come through, and everything looks pretty good. So, and it says who was permitted was 10.1.1.2. So that's pretty cool in that capability. So those are just all the ACL options that are available when it comes down to understanding how the traffic comes in and how it should be matched on. Let me show you another thing. Do show IP access list again. And one thing you'll notice is that we have a bunch of matches and a bunch of different stuff. So every one of the entries in the access list has matches. So that means that you can selectively match on traffic as you're going along and get more and more specific or less and less granular or whatever it is you might be doing. So what's cool about this is this is one of the most basic forms of firewalling that there is. What you're basically saying is the traffic comes inbound on this access list is applied inbound on the inside interface, which means it's capturing traffic before it actually hits the router. So it hits the router's inside interface on the interface. So if you were to think of it like this, to where if you were to visualize a router and you have the interfaces are on the outside of the router like this, right? On the circumference, the outer portion of the firewall, that's where the interfaces sit. Now, every router and every switch has what they refer to as a control plane. The control plane, I like to visualize that for myself as sitting in the middle of that circle. So if you think of I don't have anything on me that would be able to be representative of that. But if you look at router 18 here, you see the little, the arrows that are pointing towards it and coming back and whatnot that are showing that it's a router icon. In the very middle of that, where the arrows all meet together in the center with that plus sign, that little blue gap, that's what I like to visualize as the control plane, because all the interfaces point to the center of the router, which is where, in my mind, is where the control plane sits, the CPU sits. In a situation like that, that's where control plane policing would come into play. So you're actually catching the traffic before it comes in. That's not 100% accurate as of an explanation to how that actually works, but in the case that we're trying to understand, that's basically how I'm visualizing it and how I know which the order of operations that it's coming in. So as it sits now, we've pretty well covered this. Now, here's the thing. Let's say, for instance, you needed to add an entry in here to this access list of ACL filter somewhere up here between 10 and 13. You really wouldn't have the ability to do that, right? You have the ability to come in here and, you know, rewrite it if you wanted to, but what if you had to keep the access list in place and you needed to resequence number it? Could you do that? The answer is yes, you can. You type an IP access list and you'd be able to type in resequence and then the name of the ACL is going to be ACL Filter. Right click there, and then say, okay, what's the initial sequence number? So what is the initial number you want to run with? So we'll type in 10. And what is the incrementing that you want to do? Do you want to do it in increments of 5, 10, 30? We're just going to say 10 because it makes sense. And then we'll hit the enter key. Now if I do show IP access list, now the access lists are numerically numbered 10, 20, 30, 40, 50, 60, 70, 80. So that gives us that flexibility of being able to renumber it. But that's just that access list. If I hit the up arrow and I did this one and type in VTY access and did 10 and 10, and then do show IP access list again, now it's 10 and 20. So that's exactly what you're looking for when it comes to how this device will operate long term. So I'm going to go ahead and I'm going to exit out, and that's pretty much where this comes into play. So that's basically how I would explain how access lists work and how they operate from an extended access list perspective. Until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.